Welcome! In this lesson we're going to look at how to negate quantifiers, and we'll introduce a new one, the unicity quantifier. So let's start with negating quantifier. If we have a universal quantifier, then you could negate it by putting a not in front of it. So as an example, if we had the universal quantifier, all students at Fantes are 18 years old, and we put a not in front of it, then we would say it is not true that all students at Fantes are 18 years old. And just common sense would say, okay, if that's the case, then there is at least one student at Fantes who is not 18 years old. And if we would put that in a symbolic way, so we have here a universal quantifier. It says for all x coming from some universe, proposition x applies, and we put a not in front of it, then it says it's not the case that for all x coming from a specific universe, a propositional function applies. That would be exactly the same as there is an element x, at least one, could be more, but at least one, coming from the universe for which the propositional function does not apply. And so 18 years old with not 18 years old. So in fact, if you look at it, it means that the universal one flips into an existential one, and the propositional function is negated. Exactly the same thing happens when we start with an existential quantifier. So, for instance, if I would say there are students at Fantes that own a Ferrari, that is an existential quantifier. If I would negate it, I would say it is not true that there are students at Fantes that own a Ferrari, or there are no students at Fantes that own a Ferrari. Then of course I'm saying exactly the same thing, that all students at Fantes don't have a Ferrari. So if we again look at the symbolic one, we have the existential quantifier. There is an element x coming from a universe for which some propositional function applies, and we put a not in front of it. It is not so that there is an element x coming from the universe for which a propositional function applies. Well, that's the same, but for all elements from that universe, the propositional function does not apply. So basically the same thing. The existential one changes into a universal one, and the propositional function gets negated. We can also negate combined quantifiers, and let's just do it step by step. So here it says it is not true that for all elements from a specific universe, for all elements coming from a universe, and then these two universes don't have to be the same, some propositional function, in this case p, x, or y, applies. So if we just look at this one as one propositional function, and I would use the knowledge we had from the previous slides, then this would change into the universal quantifier flips into existential one. The universe stays the same. And then the second part I regarded as a complete propositional function. So I will just put a not in front of it. Not for all y coming from some universe, and then we have the same propositional function. And so in fact I just take step by step. So the first one means the all becomes an existential one, the complete propositional function is negated. Okay, we know this, and this changes into, the first thing is already okay. And then again, if I look at the second part, I put a not inside, so that means the universal one becomes an existential one, the universe stays the same, and the propositional function is negated. And this is called, in fact, a mechanical negation, because if you look at what I'm doing, it's just flipping the universal one into an existential one and negating the last propositional function. So just going through the complete path. If I would ask you on the exam, then don't look and try to interpret what it says, but just flip, flip, negate. And if I put 4 quantifiers next to each other, okay, we flip all of them and we negate the last one. We do that with a different combination, so just flip, flip, negate. That means the universal one becomes an existential one, domain stays. The existential one becomes a universal one, domain stays, and the propositional function is negated. That's it. Okay, just for fun, another one. Combination of 2 existential ones. So, existential one becomes universe, domain stays. Existential one becomes universal, domain stays. Propositional function is negated. And that's it. Not to worry about it. Okay, if we look at a concrete example, so we have it's not true that we can find an x from the natural numbers in such a way that for all elements y coming from the natural number x divided by y equals 2. I don't care whether it's true or false, they just ask us to change it into something without a negation symbol. Okay, let's start with the mechanical way. So, existential flips, universe stays, universal flips, universe stays, proposition is denied. Okay, but now we still have one negating symbol here. But that's of course simple. We can change this quite easily for all x, x element n. There is a y element n, in such a way that it's not true that x divided by y equals 2. So in such a way that x divided by y is not 2. Okay, not to worry. That's quite straightforward. Okay, let's do another example. So now we only have one quantifier. So the existential one changes in universal, the domain stays, and then I have to negate the propositional function. Okay. And now there is a small complication, because now we need to remember how to negate this propositional function with an and in the middle. Hopefully you remember De Morgan. So let's apply De Morgan for all x, x element natural numbers. De Morgan means x smaller 2 becomes x larger or equal to, or x not equal 5. So the not gets inside, the and flips. Done. A nice exercise. Okay, one last part. In this lesson we introduce a new quantifier, which is the unicity quantifier. And in fact, basically, it is just an existential quantifier with one extra condition. So if we looked at an existential quantifier, this E, then we could have 1 or 2 or 3 elements from the domain for which is true. That would make the proposition true. But the unicity one, and that's then the existential one with an exclamation mark behind it, then it would say there is exactly one x, it's a u, in the domain, such that the propositional function is true. So it's not allowed to have more elements. So, for instance, there is exactly one element coming from the natural numbers in such a way that x is 10. Yeah, true, of course. There is exactly one x coming from the natural numbers that x is odd. That is not true, because we have 1, 3, 5, 7. So, in this case, there is an x coming from the natural numbers. X is odd. Would be true. So there's a difference in outcome. If we look at the first example, the unicity one and the existential one will both give you a true. In the second example, the unicity one will give you a false, and the existential one will give you a true. Okay, that concludes this lesson about negating quantifiers and the unicity quantifier. And then in the next lesson, we'll look at some numerical quantifiers. Okay, see you in the next lesson.